Welcome everyone to our next presenters. They will be Simon Mattes from Schaeffler and Marvin Kunz from Wandelbots from the stand next to us. And our partners, they will be talking about physical AI and how it paves our way to autonomous production. I will ask you to just come a bit closer. Come on to stage. We have a lot of seats here. Don't be shy. Come up, and the stage is yours. Welcome. Thanks for being here.
Thank you, guys. Thank you, guys.
So, thank you.
All right. Yes, I'm happy to have Simon here from Schaeffler, and also that for the next couple, I think, 30 to 40 minutes, we will talk a little bit about how physical AI paves the way, especially at Schaeffler. And we have some exciting cases. Maybe some of you have already stopped by at our booth. We also showed them there. But now we have Simon here also as the industrial metaverse lead for Schaeffler, who was heavily involved in most of these projects that we will touch on now. And what is important for me now, which I want to touch on in this panel is actually, or it's not a panel, it's a discussion, I would say. In this discussion, I want to touch on how Schaeffler actually used different technologies like NVIDIA Isaac Sim, also Wandelbots NOVA, to really take a new approach to how they want to digitize their shop floor, but also how they want to change also how they standardize manufacturing processes. So yeah, thanks a lot again for stopping by, Simon.
Yeah, thank you for the opportunity also to talk here,
Yes. And we will also have time for questions later, so stay tuned for that as well. So Simon, just in general, I want to start with you with your role and also what you're doing at Schaeffler and what you're driving with Schaeffler, especially looking to what happened last week when you won the Innovation Award, the German Innovation Award for especially your initiative Industrial Metaverse. Why do you at Schaeffler decide to kind of go this way now, using other platforms like Wandelbots, like Omniverse, and taking a step into the Industrial Metaverse?
We have already about 4,000 robots in our CS production, starting, of course, with the low-hanging fruits in automation. But these low-hanging fruit use cases are getting rarer and rarer, meaning we have to look into more complex ones, more use cases where the economic situation is more complex, where it takes longer for the integration. We need more know-how to integrate this. And therefore, we also need new solution to make it economic, to make it fast, to make it flexible, and also with a high process stability. And therefore, our current tool stack is, in my opinion, not sufficient anymore. Not sufficient meaning we have expert tools, we have a high level of entry, we have high licensing efforts. It is complex for non-experts to go in there. We have the know-how allocated in different columns. We don't have a collaborative platform for all of our employees, no matter if you're an expert, yes or no, no matter if you are a technical guy, and also for everybody that we have a common ground, a basis understatement. And within these new tools like NVIDIA Omniverse, like Wandelbots NOVA, we try to bring the 3D world to the people. We try to develop our processes in simulation to not interfere with our serious production, and also be able to fast and efficient roll out here new solutions for more and more complex use cases. And maybe this is one of our use cases we have for our new production line in Hirscher, Germany, which we are currently setting up. To be honest, the use case itself, which you're currently seeing here, this first stage, is nothing too complex. It's just developing an automation, see what is the right robot, where to place it, what is the reachability, how to bring the parts to the stations, etc. But the important stuff now comes in within the next steps. Look, for example, at this use case you see here. We have here the assembly of a O-ring, a X-ring. It's a bending slack component. It's a prototype, it's rare, it's expensive. If we have these parts currently, we want to use it for product tests, not for production tests. Meanwhile, if you want to do the assembly of such an O-ring, you have currently to set up a hardware test. Think of a gripper design, think of how to place it, of the right strategy, program this, optimize it step by step, hardware-based. Meanwhile, if you assemble this O-ring 20, 30 times, it changes its physical behavior, it breaks, etc. And therefore we said here, well, let's not only set up this use case in hardware, within a hardware test, let's do it in simulation. And also here, I think we will also later show the example of training it to not only simulate it, to not only program it, but use an AI to train this process, which we will show you later, just also to more efficient, more faster develop the process.
Exactly, and you start with this also with having a setup of using the tools like IsaacSim, but also Wandelbots NOVA. Can you maybe walk us a little bit about why you're choosing these kind of paths as well, like looking at robot programming, abstracting that as well from just like vendor-based programming to a more agnostic layer?
Well, we started the idea of programming robots in simulation about 2021. Within a first research project focusing on the topic, and very early learned here that developing everything by ourselves is not a way to go. We have a high variety of robot manufacturers. We have a high variety of third-party, let's say, simulation to software tools, hardware connectors, sensorics. And therefore, we have to somehow standardize them. With NVIDIA Omniverse, we very efficiently found the first partner for the simulation part, also to have the physics capabilities. Physics capabilities not comparable to an FEM model, but on a level that we say it's sufficient for robotics, sufficient for what we want to do. Meanwhile, Omniverse was never the right partner to bring it to the real world because it's simply not the focus field. And therefore had now Wandelbots as the standard interface for provide a robot controller, for provide an interface to bring the know-how simulated in the simulation to the real world in a standardized way, hardware independent, and gave us the opportunity that come from a use case specific programming to a skill-based effort, meaning we one time develop a skill, one time develop an app for a specific case, and they can scale it within different hardware systems in a different environments and adapt it if necessary.
Exactly, and you touched on the physical simulation that you had. Like you said, like it's maybe a way of also organizing your production setups a bit differently. So the next example that we want to show goes more into this kind of type of simulation.
So yeah, then let's just start with the video. So this is a production line we also simulated, starting with some, let's call it dummy assets. Fast and efficient simulation, reachability, cycle time, which we can then later step-by-step adapt it to the real CAD models. An important point is here we have a drainage simulation. We have to drainage the part, and it has a complex inner geometry. It's now simplified because the inner geometry is still confidential. And within Omniverse, we were able to do this within the same expert who does the robot programming. We don't need a simulation expert. We don't need a fluid simulation expert, and could develop it also very fast and efficient to get a first impression. Meanwhile, you also saw we have the two virtual cameras here, which we use, in fact, for the quality management. The use case behind is to say, normally you also have to set up a hardware test. What is the right camera, right lenses, right distance? And here we were able to do this already in the simulation to get a much more better impression. The last tricks, the last percentage we have still to do on the real hardware, but the process to go there, the development time, the efforts is shortened down. We can, once again, streamline the hardware development, the software development, and the simulation development, and parallelize this. We are not independent from the hardware, have to wait until this is finished, then go to the software, then potentially have to restep in hardware adaptation. No, we can run it in parallel, and therefore reducing bottlenecks and faster integrate our systems.
And exactly this parallelization of these processes, you say this is something that's also going to be a huge boost for you guys in the development, not just for your departments, also for special machinery at the end, looking at projects at the same time. But how do you see like this also scale at the end, like make it more, like even more parallelized?
So currently the point is if you have a requirement sheet, if you start with it, normally you start with a 2D PowerPoint model. Meaning you have somebody who draws an automation cell in PowerPoint, converts it into a PDF, sends it to the supplier, get a new PowerPoint PDF model in 2D from the supplier back, and then you have to do a lot of adaptations because it's just an estimation of the sizes, the surroundings, etc. And within this approach, we can very early already set up a 3D environment, use this 3D environment, give it to our supplier, they can adapt it, give us the same 3D environment back. We can develop the process, the models around it, the robotics program, all in the same tool. We don't have to restart with with the development. We can reuse our know-how. We streamline the process, which is also a big efficiency gain. Meanwhile, also, of course, within the simulation, a very early stage, we understand when it comes an issue, which could be a potential bottleneck in the station, and not do it in a later stage. The earlier we know it, the earlier we can make measurements or countermeasures against this to be able to strengthen the process and faster not run into bottlenecks.
So when we look at it, you started off having, like with the first video we saw, validating new production lines, bringing it really into, I would say, a simulation layer that has physics integrated. With the second option that we saw here, you actually leveraging the physical accurate models to make sure that also adapts to your finalized robot program to make it a bit faster at the end, also in development and deployment. Because when we started now with validating, developing, you see it's quite important at the end to also bring it to life. And I think that's exactly what we see now in this collaboration together, where we as Wandelbots NOVA provide actually this layer and want to support customers like Schaeffler to really bring it at the end from not just simulation, validating it, really down to production grade lines where you can say we can securely, safely actually execute also on the shop floor. And I guess that's also one point for you where you see, okay, that's how you want to scale, right? Because otherwise, just simulating is not going to be enough, as you mentioned. Maybe you can walk us a little bit through also your process with your team. How does your team actually look at this? Because it's also different skills needed nowadays, right? Before here you had people who maybe have like some design background for a simulation. We have robot programmers that were actually involved. But now with this new process, what's changing?
So mainly when we look into our current process, the programmers, the robot programmers, the SPS, the PLC programmers are always the bottleneck. There are never enough of them. A lot of troubleshooting also to do. We have to allocate them to the most prioritized project, and for the less prioritized, there's a big bottleneck always. Within this new approach, we have the opportunity to already enable the CAD designer, the robot programmer, within all working in the same tool on the same work stream, to work more independent. We are not relying on a KUKA-specific expert or a FANUC-specific expert or a, depending on the camera system, depending expert. We can generalize our know-how. One expert can take care of the whole process chain. One expert is capable of using his know-how to jump into a new line with hardware he doesn't know in advance or didn't know in advance. And therefore, so we can generalize our know-how. We can, with the same number of experts, tackle more use cases, more use case efficient. And you always have to think of when you, for example, you rely on external know-how for setting up a specific robot which you don't have in your standard portfolio. This is always a bottleneck. When he leaves your company once again, you don't know what happened. You don't know how he programmed it. And with an holistic hardware-independent standardization, we can use one standard for the company, for every maintenance employee, for every robot programmer, for every CAD designer as a baseline, and let them work together, understand what the other one is doing, and also reuse the know-how.
Awesome. And what we saw so far was, as you said, was a planning. At the end now also what we saw here was the executing phase. But now when we talk about physical AI, right? Yes, you need the physical embodiment in the simulation environment, but where comes AI training actually into play? And that's what we're going to see now in the next part, where your case that you briefly touched on when we saw in the very beginning real quick, there is the part of a really flexible material that actually is super difficult to handle also in the physical realm, right?
Exactly. I already said that it's the prototype now. The parts are rare, they are expensive, and we also don't know the exact physical behavior. Think of the CS production can change over time, the physical behavior can change. The part we have now and the part we will have in 1-2 years could be completely different from its behavior. The banding slackness, the E-modules, etc. And that was when we said, well, not develop this in real hardware, but develop it in simulation, or develop the process in simulation, and also not program it conventionally, develop the assembly approach, develop the gripper, etc. No, use standard tools and let it train by an AI.
I'm just going to go further ahead because I think that really explains it now, how you actually use then, I would say, modern AI tools. Like for example, here we're going to talk about then Isaac Lab and how this interfaces with Wandelbots NOVA to actually create that pipeline, right? So I'm going to play the bigger video now, then you can see it. And Simon, you can comment on how that actually worked.
Yeah, you also see after 1 hour the AI wasn't capable of doing anything. After 18 hours, gripping worked, assembly still an issue. But after 24 hours of training, we were able to grip the part and do the assembly autonomously. Not developed by a human, not developed by an expert, but completely by an AI, with a standard gripper design, a standard robot from our side, only with a lot of room for exploration. And this is not the only thing we did. If you could click once further, thank you very much. We not only trained the application, we also scaled it. Scaling means let thousands of robots do the same task with different assembly strategies, different standard gripper designs from our portfolio, and also different physical behaviors of this O-ring. Meaning we were able, with this approach now, to get a solution which is far more stable than the hardware or a hardware-based development, because we can explore in such a big room of different opportunities, different variants of this program, of this process, which would have never been possible before on a hardware-based approach.
And just when did you start with all of that? When did you start with like doing these kind of new processes, like planning with like Isaac Lab, for example, planning with reinforcement learning? So when did you kick off this with your team as well?
So, like I said in the beginning, we started from a research project. Also, these are manual developed AI models now. Meaning also developing such a use case takes currently several months because it's our first tests. We're currently working on the standardization also together with Microsoft, NVIDIA, and also Wandelbots. How can we use our standard tools for standard AI workflows from a, let's call it a sandbox or a modular box, also to standardize reinforcement learning, VLMs, and also imitation learning using, for example, also NVIDIA standard foundation models on the simulation side.
Exactly, and I think that's a really important part for us as Wandelbots as well, because when we look at what the processes and kind of the ways that Schaefflers are taking now to change manufacturing processes, and how they've been done today, how they should be done tomorrow, we want to help customers to really build this intersection from robotics, like physical robotics, really intersecting with tools like, for example, Isaac Lab, making it available for training pipelines, and at the end, the really important part, bringing it back actually to the physical layer again. So having this full loop and this full cycle of we plan, validate, then train, but also execute and bring this information back and really have this continuous cycle of learning. And I guess, I don't know, when I look at the factory of the future, for me, like the next evaluation, when I talk about physical eye, it is a conscious behavior of robots. And that's the cycle that you need, right? You need a continuous learning cycle of the robotic systems. So Simon, when you talk about conscious robotics or factories of the future, you guys are leading these processes now, testing a lot of different types of processes. What does the factory of the future look like for you and maybe your view for Schaeffler?
That's a good question. So the factories we're currently having, which is about 100 brownfield factories, have machines which are 1 to 2 years old, and also machines that are 18, 90 years old, overhauled several times, but still running in excellent condition and doing their work efficiently and also successful, I would say. We're missing also details. We have no data from this machine, so the question is, at first, how do we lift these machines? How do we lift these old processes into our virtual world? When we talk about our value streams, meaning basically when we have raw material coming into one of our facilities and the material once again leaving our factories in a finished product, these processes are very hard to tackle currently. Normally what you do is one time every year you take one of the value streams, you draw on a piece of paper, identify these are the bottlenecks, and then you take your time, prioritize what are the most important bottlenecks, and one step by step try to solve them. Meaning our target with a virtual environment is at first to have the 3D representation, have the shop floor data connectivity to understand the processes, have a 24/7 actual know-how. What is the bottleneck? Where you have to change something to fast and efficient on the one side. Also understand where it is to solve issues very fast. Meanwhile, also have the idea of predictive maintenance, meaning you know what machine will fail at next. You know how to do maintenance, not do it on a every month base, do it on a base where you say you need it. Meanwhile, also have an independence from the place itself. Think of you're running in the night shift, you have an issue with the robot, you need a support from the integrator. Getting the support from the integrator at the place of interest is hard. Having the opportunity of remote support, remote optimization, also with a continuous loop. And if you develop something and if you deploy it on one place to automatically also use it in several places as well. We started here very much with the field of robotic in advance because we say robotics is a very good KPI-based use case. We can directly say these are the benefits, these are the cost savings compared to others where it's just much more complex to show, much more complex to illustrate, but now more deploying or exploring also in these other use cases as well.
And we look at these processes and look how you like now also start first implementations, also first complete loop cycles that you have like started with planning, deploying. How do you see like what are still the big blockers that you see that are in the way at the moment to like go full circle and full cycle in these kind of planning and development processes?
Well, at first for scaling we have I think 2.5 million square meters of production area. So to bring this into a virtual world is just a big effort in the thinking. Also thinking of the tier 1 supplier in automotive with TSEC regularities to onboard new solutions from the IT security side. When we think of tools like GPT, large language models of Claw, OpenClaw models, etc., how do we ensure our own data security, more important even the data security of our customers' data? How do we efficiently deploy them, and how do we then also enable our teams, not from our innovation team, but all of our 120,000 employees? You have, for example, on the idea of CAD, everybody uses 3D CAD systems. I think there's no company focusing on 2D systems anymore in the world, I guess, at least. But on the production development, or the process development, on the layout design, you're often 2D based, you're based on paper. Meanwhile, you have big advantages using 3D models. You have the third dimension, you see what interference a machine and automation itself. And getting this understanding to the people, this is more and more a step we have to go, we have to take. And yeah, this is our bottlenecks, these are our bottlenecks.
And would you say that it's more like on the organizational side, more on the technology side, or is it like really kind of a combined effort that needs to be taken here?
On the technology side, it's already there, I would say. It's working. Of course, data security is a big point. Also with, let's say, regularities which have to be adapted, have to be changed. Just think of also humanoid robots, how to deploy them, how to safe deploy them. Here simply the Normen, the TÜV-Abnahmen are not there currently. So even if the system is available, you can't just push it in Europe at least. From the technical side, we have the simulation opportunities. We know how to bring it to production. The question is, now we have the framework. How do we fill it with more and more skills, more and more, let's say, also applications that we not think of, I develop a single use case. No, I want to develop standard skills. I want to use standard skills, which I can scale into different use cases. Standard skills for gripping in a 3D environment. Standard skills for placing, for fiddling in complex things. This is more about the point we have to look on now.
So kind of building, and that's, I know we talk a lot about this often, like building a skill library for these different kind of like tasks that are being automated, and having before, like, because when you look at skills, there's all specialized tasks that really kind of wrapped into a skill, wrapped into an application that can be then also transferred. But when we look at robotics, how it's evolving, and again, coming back to the title as well, physical AI, and how maybe conscious robotics will change all of that, that means for me at the end, robots like that are specialists today, specialists and specialized in one task, one skill, for example, maybe 2 or 3 skills at the same time, but at the end, robots now need to become more generalists, right, in your opinion, to be able to adapt like to many different scenarios and can be used in many different scenarios. Like, what is your view on like specialist to generalist?
I think we have to even start one step before the robot, or beyond, depending on how many see it. So all the periphery with the grippers, the sensorics, The suppliers for them, I think they are now in charge, from my opinion, to also lift their models, make it available on the Wandelbots platform, make it available in Omniverse, that we are able to use it. There are thousands of different gripper designs on the market where we as Schaeffler maybe use a specific design just 1, 2, 3 times in the whole facility. It does not make sense if we lift it to this environment because we never have a business case beyond. But the suppliers who go to this step at first, who at first make the models available, who at first standardize them, at first use the new technologies, they are also the easiest for us to use. The models get trained on their hardware, their kinematics, their software basis, and therefore making the standard. And this is an important market advantage also compared to everybody else.
So you say like we see a shift in some companies going the way forward, and some companies like, is it also something that you as Schaeffler see, maybe we can see a pull also from companies like you, like going way forward, actually moving along and then saying, guys, we need to have like your support there as well?
I think at least we are trying, I would say. So this use cases like the one you have seen there, I think they're very important also for us to show what is possible. Like I said, this use case was one of the first that we developed, I think in 2022 or something like that, or 23, where we say the efforts for setting up this reinforcement learning pipeline were far from having a ROI behind this use case. But I know how we have generated it. We can have now the opportunity to use this now to standardize the pipeline, to give to our suppliers, say, hey, provide us the models, provide us also the kinematics within a virtual world, because then you will have the advantage compared to everybody else. So this is a little bit of the idea to use this champions use cases to go for the next steps, to convince the partners to go this way. And we will need this. And we are not the only ones who need this. And also our customers are more and more demanding for the 3D models, for the simulated models. We have it as the standard workflow. And also we see it as an advantage for us. If Schaeffler, for example, also has their own special machinery, we sell production lines. Our OEM customers want to have these models because we need it for their factory planning. We also need it as a proof, that we prove them that when they buy a production line from our side, that it will work from the first day. It will run with a high OEM in the shortest amount of time possible, because if we don't deliver, they are also not able to deliver.
So you see the value chain coming from all the way from periphery manufacturers, from robot manufacturers, but at the end also from the software layer, but even to your customers, your end customers as well, demanding this kind of change.
Exactly. And also not only that it's because of on demand, but we also see a value add behind this. We see it as an ROI, we see it as KPIs, and need to do this also to step beyond our competitors.
And also, we're coming almost closer to an end. Just to also go into like a wrap up on that thing. Like now we're at HMI 2026, right? We talked about like how you're going in the way of standing in the way of physical AI, building kind of an environment first that this is even possible with Isaac Sim, with Wandelbots NOVA as the robot brain behind it, training it in there, bringing it to the physical shop floor, and having this loop is for me the foundation. But what do you think next year, when we're going to sit here again, 2027 at HMI, what will be the next big thing that you think we will be talking about?
This is a very good question, and unfortunately I have to give a very stupid answer on this. Is now we have developed it, we have done the innovation, the first step, we have to standardize it first. Bringing the framework into the company to make it available for everybody, roll out the first use cases, which we are currently also doing. By the way, it's not that it's a future topic, it's the current topic we are focusing, and also use the lessons learned for optimize the framework, optimize the interfaces, the pipelines, finalizing the pipelines, enable our own employees to have the standard at first, but the standard must be so open that we then have to go on next steps. The next steps will be standardization of reinforcement or generally AI pipeline, also looking on vision language action models. The big points are the foundation models like NVIDIA GR00T. How do we bring this in process safe? How are we able to put in black boxes with AI models in a serious production safe, ensuring that it runs stable, ensuring that we know what it does, ensuring that it will never succeed a safety limit, a process limit, etc. And then scale, deploy skills, step by step. Also, of course, Claude GPT or OpenClaw is the next big point. So how Do we have agents who can make decisions by themselves?
I think that's maybe like an important point I just wanted to wrap up on as well. Agents, like actually have it agents in your factory, right? That actually run these kind of new applications. Do you see that as a future for Schaeffler then as well?
Data security, I see, is the most important stuff here. So there's the question which the companies like NVIDIA, like Microsoft, like AWS are also focusing. How do they make the solution safe? Because in the end, we are there more the user of the models, I would say, develop the application on the framework base. But at first, we need this I don't want to call it safe space. This sounds a little bit strange, but it's a safe environment where we have the data security declassified to also be able to roll the solutions out.
So I think that's a good way ahead at the end. Like looking at what you're already doing, testing the way, also validating now, especially like when we bring it now to the physical production, right? That's, I guess, where we will get the most benefit out of it, seeing also how this actually works at scale. Before we also wrap it all up, I wanted to also open up to the audience. If you guys have any questions, feel free. And I think we have a microphone over there. So if you have questions to either Simon or me, Wandelbots or Schaeffler, feel free and open to ask questions. If not, you can also ask questions afterwards.
My name is Sugandhar, and I have a question in the direction of how do you keep this metaverse always up to date to reality? Because once you launch this into, let's say, 30, 40 factory, as you said, 2.5 million square feet of, or square meters of factory, things change. Day to day, things change. And then you have to also bring that back into the metaverse and keep, or it's a loop, again, sending it back. How do you manage, or how do you plan to do that?
So there are different ways currently, especially when we talk about the 3D environment, which in my opinion is the thing which changes the most. We have our standard here is Navis to scan our plans, scan them also on a regular base, and then lift the data via Rico into the industrial metaverse. Meanwhile, we have specific roles in our factories, the so-called Werksdigitalisierer, or the persons focused on digitalization who have to take care to update these models. And also we have our layout planning who have to take care about also using the models. But it's still a big open point, which will be maybe also the biggest challenge we have to tackle for this year, because having a model or having a layout change, the moment from having a change till we have lifted it in the industrial metaverse currently takes several months. Not because the process itself takes time, just because we have waiting time, we have limited resources. Also, the people who scan the facilities are not always there. There are specific central people who come down to the facility and do this. But I still see this as the biggest issue. An opportunity to go is also currently going in the direction of more Gaussian splats, also where
you can see the demo on the back of the wall.
This is now a funny coincidence because we want to develop it by ourselves in the beginning to say how can we use our standard phones, our standard hardware to just film the plants, film the areas, lift it into it, and also automatically adapt it. The side project we have currently is also coordinate system matching in the facilities, that we have centralized coordinate systems so that when we have a new model that we automatically match within the existing environment. But this is a big point to go because there's also no real industrial standard. So we are using here more or less the German governance standard for measuring the country, for also measuring our facilities. That's the closest we have to a standard.
But that's actually a funny point, because at the end we always talk about the sim to real gap, but actually there's always like the real to sim gap as well. And I think that's Gaussian splatting is one point, but I think it's also like building pipelines the other way around. Like how do we actually bring a process to update always the digital assets? So it's a good point. Thank you. Any other questions? There's one.
I give it a try. I joined a bit late, but you mentioned like VLAs. To what extent are you already using VLAs, and especially like the security constraints you mentioned? Do you see that coming in the near future, or where and when?
So basically what we have at Schaeffler, we have the so-called A department, which is a bubble a pre-development bubble where we can say we can use every software tool we want without having to think of our security, but also making sure that we don't show them anything confidential. The big point with VLAs or foundation models in general is that no supplier of these models prove you that it's really working in a factory, stable, 24/7, and also makes the connectivity. So once again, we need more or less a standardization partner in between, where you more or less have a VLA block, which you have wrapped within the system boundaries around to just make the process safe itself. Still, the point of process stability is a very open point because you can't really prove how good it is. Meanwhile, also with more and more the direction of human-like robots. I don't want to say humanoid robots, but human-like robots. That a robot behaves like a human, has additional sensorics, even if they are not necessary for the process in the first idea of thinking, but also to just be able to adapt quick. That's the way to go there. But I would say at the moment from today till we have the first VLAs in production takes 2 to 3 years, in my opinion, from today.
But I think that's a good point that you touched on. With the departments that, for example, that we see also at Schaeffler and also with some other companies, I think that's really good that you drive that speed of innovation with a test bed that you can actually leverage. Because looking at these test beds, there's a bit more complexity of how, when you now work with VLAs, how the whole structure to actual execution looks like. And you can't do that just in production. And if you just go from POC to POC, that's also not really working. So I think with departments like yours is actually really helping validate that process and then really testing it on a real use case in a real production line. That's exactly what we're also doing, like when we look at what we're doing at the moment with projects with the humanoid, like human-like robot. I think that's something where you test different types of learnings, right? Imitation learning, VLAs, but also at the end, how it compares, for example, to reinforcement learning. Also.
Exactly.
Yeah. So what I wanted to say with this is just, your question is also spot on. I like the approach that Schaeffler is taking. I love that we can be partnered with that as well. But I'm really, really curious to see, with when I ask the same question to myself, what are we going to talk about next year? I really think we're going to talk about the agentic systems being on the shop floor, to be very honest, because I see a huge push. And I saw you also nodding, and I think that's exactly where the infrastructure comes in. And this is going to be a huge discussion, but that's why we're here at HMI, right? That's why we need use cases, we need drivers like Schaeffler that bring in the possibilities, but at the end we need to validate it as well and see how this is going to work. There's one more question.
I would say it's more like a comment, right? Because I mean, exactly what you are describing right now from a technology point of view and the new capabilities and abilities and what this brings into brings in as a benefit into the company. Yeah. But the other hand is, on the other hand side, the complexity is also rising dramatically, right? I mean, we already, and I think you mentioned that, Simon, in some of your words here, it's already a high complexity connecting I would say a standard shop floor, right, to have the right connectivity layer to be able to create insights. So then we have already big amount of robots, but this will arise, and then we will have to face the challenges with humanoids, right? So I mean, a good question. How will you gonna solve that? But I don't think that's solved for today, and it's happening along the way. But just to say, it's exactly the challenge for the companies.
Thank you. Yeah, I don't know if you want to comment on it, but I guess that's what you agreed on.
Yeah, that's exactly also the approach we currently have with you from the Wandelbots side. To say one common platform for the connectivity, the interface to our subsystem for the hardware independency, that we on the other side of the pipeline can now openly develop these skills, apps, and just have to connect it to the Wandelbots platform, but not to our PLCs, not to KUKA robots, separate from Fanuc, separate from Universal Robot, and also separate to the grippers. And we also see this is a necessary step that will work. If we will not do this, never work, in my opinion.
I think that was a great statement at the end. So we will see, we will see the technology pipelines being expanding, but at the end, it is all about validating it and also at the end really going for it. So thanks a lot for actually coming here. And if you want to see some of the use cases again, we will showcase them here at our booth. And the Gaussian splatting that was mentioned, there is actually a demo also on the back of this entire booth where we can show you also how this is being done and kind of where you can create a whole scene with just rendering and recording a video. Thanks a lot.
Also, thank you from my side.